Hey everyone! This week we are going to focus on solving linear equations. So, we're going to start at the beginning, solving single-step linear equations. These should look really familiar from past years of algebra. So some of you may be able to look at these equations and just think about x plus 2 equals 10. So that stands for what number plus 2 equals 10? And you could immediately say 8 plus 2 equals 10. So x is going to have to equal 8. You also might be able to look at this and say these are touching, so it's multiplying, so 5 times what equals 20. And then in your head, you could say 5 times 4 equals 20, so x is going to equal 4. However, not everyone's brain works really well in that manner, so we also have a way to do this using mathematical steps. So, for example, if we have x plus 4 equals 10, I'm wondering why do we subtract 4 from both sides? So the reason we do this is we want to get x by itself because we want to know what does x stand for. So the opposite of adding is subtracting. So when we subtract 4, 4 minus 4 equals 0. So we're just left with an x on the left side. And if you do something to the left side, you have to also do it to the right side of the equal sign. So we're also going to do a minus 4 over here. Not sure why I wrote an equal sign, just ignore that. So 10 minus 4 is 6. So we can drop down the equal sign, so x equals 6. So the reason we use subtraction when you see an addition is when you subtract the same number, it's going to equal 0. So now that number goes away. If it helps you, you can always draw the line down the center so that you know what's happening on the left and on the right, and you have to do the same thing on the left side as the right side. So for when they're touching, we know that's multiplication. So the opposite of multiplying is dividing. So I'm going to divide by 5 on both sides of the equal sign. So the reason I do this is because 5 divided by 5 equals 1. And 1x is the same thing as just a single x. And 35 divided by 5 is 7. With subtraction, same thing, the opposite is adding. And the reason we add 6 to both sides is because of minus 6 plus 6. If I did negative 6 plus 6, that's going to give me 0. So all I'm left with is an x on the left side and a 19 on the right side. Finally, when we have division, the opposite of division is multiplication. So what we're doing is we're multiplying by 3 on both sides. Notice when I multiply by 3, I'm not multiplying the denominator by 3, I'm multiplying kind of the whole fraction by 3, or really the numerator by 3. This is the same thing as 3 over 1. So 3 divided by 3 equals 1, and 1x is the same thing as x. And 7 times 3 is 21. So remember, when you see division, you can multiply by that value, and then they equal 1, so then we're just left with the x on that side. Once you find an answer, you can check it by plugging it back in. So think back to the beginning when some people are really good at just thinking like, what number plus 2 is 10? Well, 8 plus 2 is 10. So you're kind of plugging that number in for x to make sure that that equation works, and that 8 plus 2 is 10, so 10 equals 10. So we know that x is 8. So if we had something that looked like this, and I was like, I think the answer might be 2. The way we can check it is by plugging it back in for the x. So we've got the original 2, and then it's multiplying. So I'm going to write the parentheses. Plus 3 equals 7. So 2 times 2 is 4. And 4 plus 3 does equal 7. So because the left side equals the right, we know that x does equal 2, and that checks out as the solution. So it's kind of the process from the beginning where you're guessing and checking. But now you have the answer, and you're just checking if it's correct. So why don't you now try some quick practice problems, and you can feel free to either solve them mathematically or you can solve them in your head.